All right, let's talk about something in Kotlin that trips up, well, just about everyone at some point. When you're building a data class, should you be using an array or a list? It seems like such a tiny detail, but trust me, getting this wrong can lead to some of the most confusing and hard to find bugs. So let's just jump right into the mystery. Check this out. On the left, we've got a person data class using a list. We make two instances that are completely identical, and Kotlin says, yep, they're equal. Makes perfect sense. But then on the right, we change one single word. List becomes array, and bam, all of a sudden they're not equal anymore. I mean, look at them. The data is exactly the same. The structure is the same. Logically, your brain tells you these two things should be equal. So why does Kotlin disagree so strongly when we use an array? This isn't just some weird language quirk. It actually points to a really fundamental concept, and that's the core question we are going to unravel right now. To get to the bottom of this, we need to dig into what equality actually means when we're writing code. It turns out that double equal sign can be a little deceptive. There are really two different kinds of equals happening here. First up, you've got reference equality. This is the strictest, most literal kind of equality you can have. Think of it this way. Are two keys the exact same physical key? It doesn't matter if they're perfect copies that open the same lock. Reference equality asks if they are one and the same object pointing to the very same address in your computer's memory. If they aren't, the answer is always no. And then there's structural equality. Now, this is what we humans usually mean when we say two things are equal. It doesn't care about memory addresses at all. It just looks inside the objects and asks, hey, do you two contain the same stuff in the same order? Two separate shopping lists are structurally equal if they both say milk, bread, eggs. Simple as that. And here it is, the big reveal. An array on the JVM by default uses reference equality. So when we called array of 2 times back in our first example, we created two completely separate array objects in memory. Even though they hold the exact same strings, they are not the same instance. So they fail that reference equality check. A list, on the other hand, is built to use structural equality, which is why it worked exactly like we expected it to. You know what? This is why your IDE basically screams at you about this. That warning you see in Android Studio or IntelliJ is there because this is a classic trap. If you use a data class with an array as a key in a map or drop it into a set, you're going to have a bad time. You'll get these bizarre bugs where data you know is there suddenly can't be found, all because of this equality mismatch. All right, so mystery solved on the equality front, but honestly, that's just the tip of the iceberg. The choice between an array and a list goes way deeper and involves some other really important trade-offs. This table lays it all out pretty clearly. An array is mutable, meaning you can change the elements inside it, but its size is fixed forever. A Kotlin list, on the other hand, is immutable by default, which is awesome for safety, and it uses that nice, predictable structural equality. The other big things are, of course, size and that more advanced topic of type variance. For most of us, the biggest practical difference day to day is the size. An array's size is set in stone the moment you create it. If you need a collection that can grow or shrink, you can't use an array. You have to reach for a mutable list. That's what gives you all those familiar methods like .add and .remove. So you might be thinking, okay, if list is so much better for modern code, why do we even have array? Well, a huge reason is Java interoperability. Take Kotlin's handy var_arg keyword, which lets you pass a variable number of arguments to a function. Under the hood, that's implemented as an array to keep it compatible with the JVM. And that's exactly why you need to use that little asterisk, the spread operator, to unpack an existing array when you pass it into a var_arg function. Now, just when you're probably about to write off array for good, there's a plot twist. There is one very specific area where array isn't just an option, it's the undisputed champion. And that's when you need every last drop of performance. The problem with generic collections like list of int comes down to a thing called boxing. See, a primitive int is just a simple, super fast number, but a generic list can't hold it directly. To make it fit, the JVM has to box it. It wraps that simple number inside a much heavier integer object. This process creates extra objects, uses more memory, and adds a little bit of overhead for every single element. And you can see the real-world impact right here. In a benchmark calculating the average of 1 million integers, the specialized int array, which stores those raw, unboxed numbers, is a full 25% faster than the list int version. For things like game development or heavy data processing, that is a massive win. But the speed is only half the story. The memory savings are even more mind-blowing. Because it avoids all those wrapper objects, an int array uses 5 times less memory than a list of int for the exact same data. 5 times. When you're dealing with huge datasets, that can be the difference between your app running smoothly and just crashing. Phew. Okay, we've covered equality, mutability, performance. Let's boil all this down into a clear, simple guide you can actually use. So here's the playbook. If you're defining a property inside a data class, just use a list, always. It will give you the correct structural equality you expect and save you a world of pain. If you need that collection to change its size, you need a mutable list. But if you're writing super performance critical code with tons of primitives, we're talking ints, doubles, etc., that is when you reach for a specialized array like int array. And finally, when you're calling a var arg function, you'll need an array and the spread operator. And this brings us to the final thought. The array versus list dilemma is a perfect example of a tiny choice that has these deep, hidden consequences. It really makes you wonder, doesn't it? What other seemingly simple choices in our daily code are hiding these kinds of performance or correctness traps right under our noses? Something to chew on. Thanks for watching.